Today we are going to study chapter 19 and we'll be studying electric forces and electric fields. The first thing we'll be going to study here is Coulombs law, and Coulombs law states the force between two charges when they are brought at a certain distance to each other. Now suppose that we have two charges Q1 and Q2 which are at a certain distance. They will apply a force on each other, which will be, because they are of opposite sign, the force will be attractive force. And from Newton's third law, these forces will be equal and opposite to each other. Similarly, if these charges, they are of the same sign, they will apply a repulsive force. So 2 will apply a force on 1 towards the left and 1 will apply a force on 2 towards the right. And these forces, they will always be along the distance, along the radius which joins, the line joining Q1 and Q2. So the forces, they always act along R vector. It might be opposite or towards, but it will always be along this axis. Okay. So based on this, the Coulombs law states that any force, it might be 1, 2 or 2, 1. This force is given by a constant into charge Q1 and charge Q2 divided by the distance squared into R12 unit vector. Now force and the unit vector, they are saying. So this means that this force and this unit vector, they are in the same direction. Now, but we did not mention here what is R12 unit vector. Now let us try to understand this R12 unit vector. Now we just said that the forces and the force always acts along the distance between the two charges. So if we bring this charge Q2 near Q1, then it will apply a force. If it is a plus charge, it will apply a force towards the right by this charge and along the radius. The force is not along this direction or this direction or this direction, any other direction, but it will always be along this direction. It might be towards right or it might be towards left. Now let us say we're talking about F12 vector. Then the radius vector from 1 to 2 will be R12 vector, and the unit vector will be along the vector, so it will also be along the same direction, and force, is in this direction. So it means that F12 and R12 vector, they are in the same direction. Similarly here also, if the charges are the same sign, the vector from here to here will be R21 vector, force will be F21 vector, and vector and unit vector, they are in the same direction. So the force and unit vector, they will be in the same direction. Similarly, if the two charges, they are opposite in sign, then the force, first of all check the force. Because they are in opposite sign, the force by 1 on 2 will be towards the left, while you know that the R vector will stay the same, so the R vector is towards the right. And R unit vector, they will have the same direction, so R unit vector will be also in the same direction, so they are opposite in direction. Now we can also write Coulombs law for this one. So we can say that the Coulombs law for this will be K into, now we have Q1 which is plus charge, so plus Q1 minus Q2 into R12 unit vector divided by R square. So what we get from here is that plus into minus will be minus here. So from here we find out that this vector and R unit vector, they are opposite to each other. So this is how R12, R unit vectors and forces, they are related to each other. So this will be the Coulombs law. And if we have to find out the magnitude of this, it will just be a magnitude of this quantity, and magnitude of R unit vector. Because it is a unit vector, it has a magnitude of 1. And therefore, this entire magnitude will be only Ke Q1 Q2 upon R square. And these two forces, they will be equal and opposite, but their magnitudes will be equal. Let us say that collectively they are equal to Fe, the electrostatic force between the two charges Q1 and Q2. Where we have used this constant Ke, which is called a Coulombs constant. And if we have to find out the unit of this constant, it is very easy to find from here. We can use this relation, which is the magnitude part, and because force has a unit of Newton, charge has a unit of coulomb, R has a unit of meter, it's the distance, so it will be meter square. So Ke will have a unit of Newton meter square per coulomb square, and it has a constant value which is 9 into 10 to the power 9, and units will be Nm square upon coulomb square. And it is also given by 1 upon 4 pi epsilon naught, where epsilon naught is a constant which is called permittivity of free space, and it has a value around 8 into 10 to the power minus 12, and the units will be a coulomb square divided by Newton meter square. Okay, that's all for now.